Hello guys, we are going to discuss today the condition for a particle to complete vertical circles. Okay, you have to see that, for example, there is an object which is hanging from a point O, let's say, with a string, and here is the string. Okay, and here is that object, and let's say its mass is m, so its weight is going to be mg. Okay, so basically the condition for a particle to complete vertical circles is that if you, like, for example, if you look at this particle, this is right now in equilibrium, hanging in equilibrium from this point O with a string. So if you project it, you give this an initial push, you give it an initial velocity so that it starts moving in such a way that the string is taut. Okay, so the condition is that the initial speed should be greater than or equal to the square root of 5gr. Only then this will complete the vertical circles. We are going to study in this video that why do we have this condition for a particle with the mass m to complete the vertical circles. Okay, before I start telling you, before we start proving this condition to be true, we should recall that for a particle moving purely under gravity, for example, let me give you an example here. There is a particle, let me draw an inclined, like, surface here. There is a particle, we are just going to draw it from this point. Okay, and let me draw this horizontal line here. Now this is the height h. Okay, there is the theta, the mass is m. So at this point, with the mass m and the height h, its potential energy is going to be mgh. Okay, that is the potential energy. And since we're going to drop this, we're not giving it an initial push here, so its initial velocity will be 0. So at this moment, its kinetic energy is going to be 0. Okay, now this is purely moving under gravity. When it reaches this point over here at the ground level, here the height is going to be 0, and let's say its velocity is now v. So now because of this height 0, its potential energy is going to be 0, and because of its speed v, its kinetic energy, that is going to be half mv square. Okay, now this mgh plus 0 is going to be same as this half mv square plus 0. And this is the law of conservation of energy, that the energy is neither, it can neither be produced or nor be destroyed. Okay, so for any point on this track, you take any point and you find the sum of the potential energy and the kinetic energy, that will remain the same throughout, though there would be the changes in the potential energy because of the changes in its height level, and there would be different kinetic energies for different velocities over this track. But at any point, the sum of the kinetic energy and the potential energy will be same. Now we shall be using the same law of conservation of energy to prove that condition, that the initial speed should be greater than or equal to the square root of 5gr if any object has to complete the vertical circles. Okay, Now let me erase this. Now, at this level, we have given it a push with the initial speed u. Okay, so I'll be mentioning here that like there will be an initial case and then there will be a general case. Now initially we have potential energy. Now this radius is r, so that is, now this is the level from which we're going to determine the potential energy. So at this level the potential energy is 0 because this is the ground level maybe. Okay, so or the level from which you're going to determine the height of this object. So that is why this potential energy over here is 0. The potential energy at this initial level is going to be minus mgr, because this is going to be r units below this O. At this point this is r units below this O, so the height is in a way minus r. That is why the initial potential energy is minus mgr, and the kinetic energy, we shall be writing that in terms of u, that is going to be half mu square. Okay, now we shall see that in general what will be the potential energy and what will be the kinetic energy. Okay, now suppose I take a general position over here. There is the, let me call this position A and this is the position P over here. Okay, and here is that string. Now there is a tension T in it. Okay, and here is, let me show you the its weight, which is going to be mg. Okay, and yeah, this should look to, you must like to me it's looking to be vertically downwards. So these two lines, they are like, you know, vertically downwards, the black and the red one, mg. So I'm wondering, like, okay, that might be the position of my phone's camera. So this mg is downward, this black, like written in black, mg is also downward. Okay, now here is the theta. Obviously when we talk about the circular motion, we purely depend on this theta, that how much this is being like rotated. Okay, now at the moment, what do you think, what is the potential energy right now? You will have to resolve this radius. This is radius as well. This red line showing the tension, but this is showing the radius as well. So this is, if this is theta over here, this is going to be theta here as well. So this is basically r cos theta. So you see that from this level, this is r cos theta below this point, I mean this dotted line which is passing through this O. So we can say that generally the potential energy is going to be minus mg r cos theta. Now what about the kinetic energy in general? So the kinetic energy would be, we are just going to assume that right now there is this is the velocity v over here. So the kinetic energy is going to be half mv square. Okay, now from the law of the conservation of energy, we can say that energy, the sum of the potential energy and the kinetic energy at the point A is going to be same as the sum of the potential energy and the kinetic energy at the point P. Okay, so I shall be writing this minus mgr plus half mu square, that is equal to minus mgr cos theta plus half mv square. So I have this big equation over here, okay? Now, from this equation, I'll be taking out the value of mv square. Now, why I will be doing that? Because if you remember that we have been using this previously as well, that when you use this f equal to ma, so this a over here, it is going to be either this a is v square over r, or this is r omega square. So since we are talking about the velocities over here, so we shall use this formula v square over r. So this f will be mv square over r. So if I take out the value of this mv square, and then I can, if I put this into this, you see this is a lot of algebra again involved over here. People start taking this further maths or even your A-level mathematics difficult because of the very extended level of the algebraic skills which are required to derive the new equations and show these conditions being true in these cases. Okay, so just be brave. Okay, so we shall find this mv square from here, okay, so that I can put that back into this f equal to mv square over r thing. Okay, so this half mv square is going to be equal to minus mgr plus half mu square and then plus mgr cos theta. So this mv square, I have this over here, it is going to be minus 2 mgr plus mu square and plus 2 mgr cos theta. Okay, now I'm going to erase this part because I need some space for further working. Okay guys, now after this since I told you that we have to use this formula f equal to mv square over r. Now this f over here is going to be the resultant of the forces acting on our particle. Okay, now you see there is one thing is the weight of this particle and the other is the tension in the string that is making this move in this circular locus. Okay, so we have to resolve the weight in the direction parallel and perpendicular to this tension. Okay, so I shall be extending it like this, remember, like this, and this is the weight. Now the whatever thing is being resolved, that always becomes the hypotenuse. So that is a key of, like, if you want to be good at resolving. So this is going to be parallel to this v, so like this and this. If this is theta over here, this is going to be theta. Okay, so now this is going to be mg cos theta. I just need this one, mg cos theta. So the net force on this particle right now is T minus mg cos theta. Okay, so now I'm going to use that this T minus mg cos theta, that is equal to mv square over r. Okay, now since we have mv square over r, so something that I obtained from the law of conservation of energy, this equation, I'll be dividing both sides by r so that I have exactly something that I want. Okay, so you see that this r is cancelled by this r and this r is cancelled by this r. So now I have this Let me change this marker. Now this is going to be t minus mg cos theta. Instead of this mv square over r, I'll be writing this minus 2mg plus mu square over r, and then plus 2mg cos theta. Okay. Now whenever you assume that your object is completing the vertical circles, then you have to be very sure that when the object reaches at this point, let me call this point as point B. At this point, its velocity should not be zero. Okay? Or in other words, the tension should not be zero over here. Okay? If the tension is less than if you look at this because of this tension over here, this is moving in circles. Okay, so this tension has to be positive, only then this will complete the circles. Okay, now meanwhile, when it reaches the point B, what do you think? What is this angle now? This angle is going to be 180 degrees. Okay, so and again, if you remember, if you recall that projectile thing, when it has like vertically, this is the highest position over here. Okay, so when a particle reaches the highest position, its final velocity is zero, but it has to be not exactly zeros. If it is more than zero, only then this will keep on moving like this. Okay, so I am going to put theta 180 degrees over here. When I put theta as 180, so you must remember that cos 180 is minus 1. Okay, cos 180 is minus 1. So this becomes t plus mg, that is equal to minus 2mg plus mu square over r, and this is minus 2mg because your cos 180 is minus 1. Okay, now this t is going to be minus 5mg plus mu square over r. And as I told you that if it has to complete the vertical circles over here, its tension should be greater than or equal to 0. Okay, so I put that greater than or equal to 0. So you see that this becomes mu square over r is greater than or equal to 5mg. This m is cancelled with the m. Okay, and finally we have u square is greater than or equal to 5gr, and this u is greater than square root of 5gr. So that is what we wanted to prove over here, that if an object has to complete the vertical circles, its initial speed should be greater than or equal to the square root of 5gr. Otherwise, this object cannot complete the vertical circles. Thank you very much.